Here we have largest element in an array problem. The problem statement says that we have an array. Our task is to find the largest element and return it. Let's see some examples. The first example says that we have an array with values 1, 8, 7, 56 and 90. So the largest element would be 90 and we have to return that. Okay. In the next example, we have all duplicate values, that is 5. And in this case, 5 will be the largest element. Got it? In the last example, we have a single element present in the array and which itself will be our answer. So we have to return 10 as the output. Also have a look over the constraints. The constraints clearly specify that there will always be at least one element present in the array. So with this, the most straightforward approach that I can think of is that we can apply sorting. If we choose to sort the array in the ascending order, so then naturally the largest element would be the last element of the array. And if we choose to sort in descending order, so the first element would be our largest element. So if you would be presenting this solution to interviewer might expect more optimal solution from you, because this solution will be taking order of n log n time because of sorting. So here comes our second approach. We will be assuming that our largest element is the first array element. Okay. After this, we will be traversing from the second element towards the end of the array. And on each scan, each traversal, we will be checking that if the current array element, if it is greater than the assumed largest, if yes, so we will be updating the largest element. Also, stay tuned towards the end of this video because I will be sharing a cool ES6 way to solve this problem in just one line. Okay, so without further delay, let's move on to the code. Let's code the first approach, which was we have to sort the array. So I will be using the built-in array methods to sort the array. I am opting to sort in ascending order. So if I am opting to sort in ascending order, so naturally my largest element would be towards the last index, right? So I will be returning that. So let's see if it passes the custom test cases. It passes. Let's submit this. Great. So now we can move towards the approach 2. Okay, approach 2. In approach 2, as discussed, we will be declaring the largest to be array of first element, right? Now we will be traversing from the second index, right? Which is 1 and towards the end of the array. Okay. In this traversal, what we will be doing is we will be checking if my array of current element, if it is greater than the assumed largest. If yes, so then I can simply say that just update my largest flag to be as array of ith iteration, right? And after the loop ends, we can simply say that return our largest. Let's test this. Okay. And now let's submit it. Great. So we are able to solve our problem with the two approaches. So as promised, let me show you the cool ES6 way to solve this problem. So in order to solve, let me just comment this, and I need to explain you two concepts. So I'll be putting certain console logs. One is I'll be spreading out my array. In the next, I'll be writing console.log of math of maximum of two numbers. So let's suppose 2, 3. In the next, I'll choose console.log of math.max of 1, 2, 3, 600. Okay. And in the last one, I'll do a console log of math.max of this array, spreaded array. Okay, so let's see the custom input with our outputs. So if you see, the first output is we got the entire array with the spreaded operator, got it. And in the next, out of 2 and 3, 3 is the maximum, which is our answer, which is being logged. In the next, we have 1, 2, 3, 6 and 100. Out of this, naturally 100 is the maximum. And if you see next, we have math.max on the entire array, which is this one. So if you see, 90 is returned. So this itself is the solution. We can just simply return this and this will work. But I'll further optimize this entire function as well into one line, because this is as of now in 3 lines. So let me write largest equals to, I'll take this anonymous function and use the arrow syntax, and we'll simply say this line math.max and the spreaded array, and that's all. Let's compile and run. Cool, it passes the custom input and it will also pass the test cases. Okay, so now coming to the time and space complexity, coming to the approach number 1. So if you see here, we are performing sorting. So the time complexity will for sure will be big O of order of n log n, right? And what about the space complexity? It depends on the algorithm actually for JavaScript. So there's some debate that if we use quick sort, so certain algorithms have a space complexity of order of 1 to order of log n and order of n. So we can roughly take the space complexity big O of n. In the next approach, the time complexity will be order of n. For obvious reasons, we just have one traversal, right? So for space complexity, we just have one variable. So it will be order of 1. So for this one, right? So coming to the ES6 way of this solution, here we have spreaded array. So this spreaded array is equivalent in terms of for loop and while loop. So the time complexity for this itself is order of n, and this math.max, what it does is it will basically time complexity for this itself will be order of n. So now you would be wondering that this could be order of n square, but it's not like that. So the time complexity is big O of n plus big O of n, which sums up to be big O of n only. Okay, and what about the space complexity? So the space complexity due to math.max would be order of n. Okay, so the best optimal approach that you should present to the interviewer should be this one. Thank you.